we looked at yesterday when we're talking about concavity. We know the function is concave up when the second derivative is positive, concave down when the second derivative is negative. I think the new vocabulary word we did yesterday was this point of inflection, which is going to be where the second derivative changes signs, which implies where the concavity of the original function is changing. So the process for finding intervals of concavity and the point of inflection is basically the same as intervals of increasing and decreasing, except you're just doing it all with the second derivative versus the first derivative. So I'm going to go ahead and give you an example to try first. Like we'll do it together, but I want to give you a chance to find the second derivative on your own first. So yeah, I'm going to go ahead and say try this one. Again, you're going to find the first derivative and then find the second derivative. To make sure you're not starting this incorrectly, make sure you interpret that as x times the cosine of x. There.
So I get that part because 0.
Mm-hmm.
But what do you mean find where x?
That's where given denominator instead of denominator. We know that you can't divide by 0 now, so you also want to find the derivative or second derivative inside the line. So again, I do want you to find the intervals of concave up and concave down. So once you find that first derivative, to make the math easier for you, simplify that first derivative completely, and then go and find that second derivative. I'm going to give you a moment just to try that first, and then we'll check what you did. If you're checking the first step, that's what you should have gotten for the first derivative. So that first factor is x times cosine. So you need to make sure you do the product rule. Also need to remember that the derivative of cosine is negative sine of x. And then the derivative of that second term, minus 2 sine of x, which is going to become minus 2 cosine of x. And I do want to simplify this, so there are some like terms. So like this first term, I just kind of rewrote it as negative x times the sine of x. But then those last two terms, I have a positive cosine, and I'm taking away 2 cosines. So what's left over is just minus cosine of x. So I would use this one if I want to do the intervals of increasing and decreasing. But I do want to make sure I'm doing concavity. So I'm looking at the second derivative. Well, we have another product here. We can think of this as negative x times sine of x, if that makes it easy for you. But go ahead and find the second derivative if you haven't already, and then that's what we're going to use to find those key values. So there's my second derivative. That first term in the first derivative I can think of as negative x times sine of x. So I did the product rule. The derivative of sine is positive cosine, so I have negative x times cosine plus -1 times sine of x. And then for this term at the end, minus cosine, the derivative of cosine is negative sine, so that double negative is where that plus sign is coming from. So this is what we're going to set equal to 0, and then also figure out where it's possibly undefined. But simplifying first, those last two terms, we basically have a negative sign and a positive sign, so they end up canceling each other out. So my simplified second derivative is negative x times the cosine of x. So if I'm looking for key values on my second derivative, we know that is going to occur when the second derivative is equal to 0 or when the second derivative is undefined. We often have to be careful with trig. Sometimes there's hidden denominators, and that's where the derivative is going to be undefined. This is just cosine, so similar to yesterday, there's not going to be a part here where this derivative is undefined. So we can go ahead and set this part equal to 0. So I have 0 is equal to negative x times cosine of x. Don't think of this as anything too strange. This is basically a factored answer already. Like you have negative x times the cosine of x. We know in math, if we have factors equal to 0, then we can just set each of those factors equal to 0. So I have one equation where negative x is equal to 0. So x itself is equal to 0. The other equation is cosine of x is equal to 0. And then we can think about our unit circle to solve that. One thing we do want to be careful with trig, you'll always have an interval. This interval is going from negative pi to pi, so it's a little bit different from like saying 0 to 2 pi. If I'm thinking about the unit circle for this one, so we know pi is at 180, so it's like going around counterclockwise. But if I'm going backwards to negative pi, it's like you're moving backwards through the fourth and the third quadrant, and that's where negative pi is at. So we do just want to make sure we give radian measurements that are within that interval. And what I mean by that is we know that cosine is equal to 0 at two places on the unit circle. Cosine is equal to 0 at pi over 2 and 3 pi over 2. But the issue with that 3 pi over 2, it is not within the interval from negative pi to pi. 3 pi over 2 is greater than pi, so instead of using 3 pi over 2, we're going to use negative pi over 2 because that is within the given interval. So these are our important points. We don't call them critical points. Again, we save that just when we're setting the first derivative equal to 0 and when the first derivative is undefined. But now I can go ahead and make my sign chart with the second derivative. I'm going to put my reminders here that this has an interval on it going from negative pi to positive pi. And then the key values we have, putting them in order. So I have the negative pi over 2. I have 0, and then I have pi over 2. Different ways you can list your factors for this one. Some people like just listing two factors, so like negative x and then cosine of x. For me, whenever I have a negative, I like kind of giving it its own row, but you don't have to. So when I see this one, I see the factors as being -1, x, and then the cosine of x. I like splitting it up. To me, it makes it easier to find the sign of those factors. Like -1 is easy. -1 is just a number. It is always negative, so it will be negative in all 4 of those intervals. The factor of x will be negative when you are less than 0 and positive when you're greater than 0. And then cosine, I just kind of think about the unit circle since it is just a factor of the cosine of x. If we're from negative pi to negative pi over 2, I just wanted to let that off there. From negative pi to negative pi over 2, that is the third quadrant. Cosine is negative. From negative pi over 2 to 0, that is in the fourth quadrant. We know cosine is positive. From 0 to pi over 2, cosine is positive. And from pi over 2 to pi, cosine is negative. I keep messing up. Negative. And then from there, we can figure out what the intervals are overall. So that first interval, we had a negative times a negative times another negative. 3 negatives makes that whole interval negative. Next interval, 2 negatives makes it a positive. 1 negative makes it a negative. 2 negatives makes it a positive. Remember, the sign chart does not count as your final answer. On the AP exam, you will need to kind of state your answer clearly and justify it. So we can see that this is the function y. Y is concave down, I'll do first, on the interval from negative pi to negative pi over 2. Union 0 to pi over 2. How do I know it's concave down there? Because the second derivative is less than 0. We can also see that it is concave up, looking at my sign chart. Y is concave up on the interval where my second derivative is positive. So from negative pi over 2 to 0, and then from pi over 2 to pi. I know it's concave up there because the second derivative is greater than 0. And then we have that last word we use, the point of inflection. Again, the point of inflection is where the sign of the second derivative changes signs. So looking back at my sign chart, it goes from negative to positive. So negative pi over 2 is a point of inflection. Positive to negative, and negative to positive. So 0 is a point of inflection. And then pi over 2 is also a point of inflection because we do see that it changes signs on either side of it. How do we justify our answer that something's a point of inflection? You don't have to state clearly that the second derivative is changing from positive to negative. You can just kind of say in general, the sign of the second derivative is changing. So I need more space. X equals negative pi over 2, 0, and pi over 2 are points of inflection on y. How do we know that? Because the second derivative of y changes signs. And again, one common mistake I see with points of inflection is people just read the numbers that they put on their sign chart. If that second derivative goes from like positive to positive, that x value in the middle would not be considered a point of inflection. Any questions on that problem? All right. So I'm just going to let you have the rest of the day to work. I know it's Friday. I think if you started that homework, you probably saw that there is just like a lot of algebra you have to worry about. I do think that is the hardest part with the second derivative, especially when that first derivative is not the friendliest. Looking at next week, remember next week is kind of that weird week. I'm not doing anything extra on that Tuesday and Thursday. So if you're looking at your week next week on Monday, we're just doing a review day. So I have one problem where we'll find both the intervals of increasing and decreasing and the concavity of them. I did just share it with you in OneNote in case you got bored of the weekend, I guess, and wanted to look at it. Wednesday of next week is going to be your quiz, and that quiz is just going to cover those 4 new derivative rules we learned, the 2 exponential ones and the 2 log ones, and then also our key intervals of functions, and then the point of inflection. And then Friday would be a new topic that we're going to look at, but still related to kind of making sign charts and all that. So I'm going to go ahead and let you get started, and I'll answer questions. I'm going to answer questions for people who are at home first, and then I'll come around and answer questions for people who are here at school. But y'all can go ahead and get started. I'll put the homework in if you need the reminder.